Okay, welcome back. We're at the end of what we call our preparation quiz. Uh, so what we'll do here is we'll go ahead and tackle these last three problems, 9, 10, and 11, as one. Each one a step at a time. Okay, the first one is, what is the synchronous speed of the magnetic field in this motor? Okay, it's an induction motor, so it has a rotating magnetic field primarily produced by the stator windings and their behaviors when they're attached to a three-phase AC power source. Okay. Uh, and then some subsequent questions that go with that. How many pole pairs are there for this motor? And the 11th one, problem 11, is calculate the RPM slip for this motor. All right, so we're going to do those three. We have to have something to tell us something about the rotating magnetic field for this motor. Okay, so if I look around here, I've got a box here in my table, a cell, and it says that the full load RPM of this motor is 1,760, and that is in RPM because it says so right there. Okay, now then, let's just talk about a couple of things here. I think this is a good sheet to use for that. I don't know how well you can read it, but I'm gonna try it because you will have a handout when I see you next. AC motor speeds. This is primarily talking about we're talking about three-phase. Okay, so we have two of them. They look alike, okay, but they're deceptive in the fact that in the denominator of this relationship is different than the denominator of this relationship. Denominator here says pole pairs per phase, and I want you to pay attention to the fact that it is per phase. This one down here says poles per phase. Okay. Do I have an illustration for that? I've got a small one here. This is the end view of a stator with the rotor removed. And I've got line 1, line 2, and line 3 electrical lines coming into the motor. And I have a total of 6 poles in here. But what I'm interested in is how many per phase. Okay, so if I've got 6 poles, 3 phases, I've got 2 poles, 2 poles in each phase. Or I can say I've got a pole pair in each phase. So the math relationship for that, if we're going to be talking about pole pairs, we use this equation right here. If we're talking about poles per phase, we use the second equation. Now notice the only difference is a constant of 60 in this one and a constant of 120 in this one. I've got a chart right here below it, and you'll notice that this one talks about the synchronous speeds of AC motors. Okay. But when we talk about the poles, it talks strictly about poles. It never mentions pole pairs. And let me caution you to be sure that you know what you're talking about, okay, or that your coworkers know what you're talking about or what they're talking about when you mention pole pairs or poles per phase, pole pairs per phase, or poles per phase. All right. So. The question that we had was, what's the synchronous speed of the magnetic field for this motor? Well, the full load RPM is 1760. The synchronous speeds have to be a whole number. The synchronous speeds have to be a whole number, and the actual speed will be slightly below that whole number. So I've got 1760 here. I'm operating at 60 hertz. 60 hertz is right here. I've got 1800 for 4 poles per phase. That's correct. So this is the motor I have. My synchronous speed of the rotating magnetic field produced by the stator is 1800 RPM. The actual speed, or the rotating speed of the motor, is 1760 RPM. You see there's a slight difference between the two. So how many pole pairs are there for this motor? Well, there are 4 poles per phase, or you can say 2 pole pair per phase. Slip. An induction motor has to have slip or it will not rotate. For the motor we just talked about, okay, we can calculate the slip. Slip is equal to the synchronous speed, which is 1800 RPM for our motor, minus the actual rotor speed, and we saw that. It was 1760 RPM. And again, the denominator has the synchronous speed and nothing else in it. Okay, slip is equal to the synchronous speed minus the rotor speed divided by the synchronous speed. So 1800 RPM minus 1760 RPM, all of that divided by 1800 RPM. So that gives me an answer of 0.0222 or 2.2%. Okay. For Group 2, I'll see you tomorrow. Group 1, we talked about this. There will be an online final quiz coming. It'll be another nameplate, hopefully not too radically different, but you need to get this down pat if this is not set with you already. All right, I'll see half of you tomorrow.